Hello everyone and welcome. In this video I'm going to be introducing logarithms. Now before I get started, I just want you guys to understand that what I'm talking about today is just an inverse function. We've discussed lots of inverse functions. There's lots of quadratics that you can solve and try and find their inverses, and it's pretty easy, it's pretty simple. You're just switching the x and y, right? You're going from input, instead of input to output, from output to input. Now in this case we are doing the exact same thing. We start with input, we go to output via the function, a process, and then to go from the output back to the input, you need the inverse process. Now, what makes this so special, like why did I have to have a specific and separate lesson for logarithms when all there are inverse functions, is the fact that you actually can't get the inverse the same way you can get the inverse for any other function. If you had y equals x squared, to take its inverse you'll just switch the y and x, making it x equals y squared, take the square root on either side, choose whether you want it positive or negative based on your domain, and then write it as f inverse of x equals the square root of x. This is your inverse function. To get the inverse of y equals 2x, you just switch between the x and y and make y the subject, and then switch with y to become f inverse equals to x over 2. Right, this is how to get the inverse function. But now I'm asking you to get the inverse of an exponential. An exponential means a function that has x in the power, okay, never as base, only in the power. So say what you call that, it's y equals to 2 to the power of x. To get the inverse of this, I'll try maybe switching between x and y. That's my first instinct. Alright, what? You can't do anything after this. You can't take the y through. That doesn't exist. And even if you did, like where does that get you? It doesn't get you any closer to where you originally were. And therefore there is no way to get to the inverse that is using this method. And so we had to have it be separate, because we understood that we had to think about it more in order to understand the inverse. The inverse here doesn't come through a certain process. It doesn't come through switching the process and there you go. No, it actually comes via logical thinking. When we first were introduced to exponentials, we talked about them in terms of time, right? We talked about compound interest and formulas where basically the power was usually time. Now I want you to go back to these days when we used to think about x in terms of time. And think about what the question this equation is asking of you, right? When we were in first grade, we used to, let's say, translate word problems to equations. Now I'm asking you to translate this equation to a word problem. So let's say it was a to the power of x. Okay, the question here is probably, what is exactly the value of y after you have left a to increase in size for a certain period of time, if we think about x in terms of time. Okay, so what's it called? How big is y after you've left a increase in size for a certain period of time? Right, we're asking for y and we're making it such that x is time. Okay, now in order for me to go to the inverse function, then I must ask about x. Right, so again here I'm asking about the value. Now I want you to ask about the time. So to ask about the time means how much time will it take, for example, for a to become y in size, right? So like how much time, that's x, will it take? How much time will it take for a to become y? Well, we don't really have any process that indicates what I'm saying, right? We have a process that indicates the multiplication, we have wording that indicates subtraction, the difference between, we have wording that indicates what's it called, addition, that's the sum of, right? We don't have a wording that indicates, well, how big will it get after I've left it for a certain period of time. How much time does it take for something to go from one size to another? And so a mathematician said, okay, then let's create one. And he said that let's make this wording, let's make this log, okay? And we're going to be writing log inside the process to indicate that this is actually what I'm doing. I am going from a certain size to another, and I'm asking for the time that it took for me to go through that process, right? And so here I'm going from size a, I write a at the bottom, and then I go to size y. This is a logarithmic function, okay? And it's exactly the opposite of your exponential function, okay? Now, I would like you guys to know that I am going to be like switching a lot between exponential to logarithmic functions. Therefore, we need to carry a process in order to like read this logarithmic function, right? Just like we're able to read multiplication, we're able to read division. I want to be able to read logarithms in order for me to solve with ease. Okay, because if you can't read something, then do you really understand it? Let's see. So here in order to read this, I'd say x equals log of y to base a. Okay, so x equals log of y to base a. Obviously, it's up to you to choose how to read it. Like, for example, people can read multiplication as x into 2. For example, x times 2 is x into 2, or x, the product of x and 2. Like, it's up to you to choose how you want to say it. For example, I prefer saying it as how long will it take for a to become y? That's log of a to become y is equal to x. Okay, that's how I prefer to read it, but I prefer that you guys read it as like how the examiner would prefer you reading it as log of y to base a. Okay. Now, just like any function, this is an inverse function, right? But I'm going to be dealing with it from now on as though it's its own function. Okay, I'm going to be using it to solve for x. I'm going to be using it to solve different functions, and we have different laws. Just like in the case of exponential functions, we have exponential laws. Here we actually have different logarithmic laws, which I'm going to be covering in the next video. Anyway, thank you guys for watching. Have a nice day.